7.5b, properties of logarithms. We're going to solve equations this time. And in order to solve this problem number one, you're going to have to use the properties of logarithms that we talked about yesterday. So let's review real quick what we talked about. When there was a log x plus log y, we changed that into multiplication. We want to put two logs into a single log. All right, that was one of the properties that we learned yesterday. And likewise, when there was a subtraction, log x minus log y, we can condense into a single log if that operation is division. And the other one that we had, let's see if I have room over here. Let's say we have log x to the third power, right? Log x to the third power. We pulled that exponent around the front and called that 3 log x. All right. So we've got three different kind of rules that we use over and over and over again with logarithms, and you're going to have to do that in this problem number one. You're going to have to use that property. So in problem number one, the thing you should notice is there are two logs. We don't want two logs. When we solve an equation, we want to isolate the variable. That involves a lot of the times combining like terms or whatever. And in this case, we're going to have to combine those two logs into a single log. And it's not that hard to do. You just have to notice that you're subtracting two logs. So it's going to look like this over here where we subtracted two logs. All right. You can condense that into a single log base 8 if you change the operation into division. So just copy down the other side of the equation. So we condense to a single log. And now what we can do, and I talked about it briefly yesterday, but in order to isolate x, we're going to need to get rid of the divide by 4. We'll do that later. We've got to get rid of the log base 8. And we know that a logarithm has something to do with an exponent, right? Or an exponential. In fact, they are inverse operations, all right? So all I have to do to cancel out that log base 8 is I'm going to take a base 8 on both sides. Now, it seems like that's a waste of time because all that does is just cancel this out and leave me with everything else. X over 4 equals 17. X over 4 equals 17. And so then now it's just a straight solve. I'm going to, cross multiply or whatever, multiply both sides by 4. That's what you want to think about. X is going to equal 17 times 4. What is that? 68? 68. Now, the last thing you should probably do is plug in your answer and see if it's positive. We don't want negative numbers, okay? We don't want a negative inside of a logarithm. So as long as that's positive, you're fine, okay? Now, that was a lot of talk. Now we can go faster. What you have to do in this problem, number 3, is notice that that's a plus. We can condense to a single log by changing plus to what? Multiplication, right? So that's x times 2, or we could just say 2 times x. It doesn't matter if we switch it around and say x times 2 or 2 times x. It doesn't matter. So just like the last problem, the reason why this is going to cancel out is because I'm raising the logarithms into an exponent. All right, 8 to the log base 8 is why that cancels out. That's not multiplication. I'm not multiplying by 8. I'm taking the base 8 on both sides. I'm raising the logarithms up into the exponent. But that cancels out and leaves me with just 2x equals 44. Divide by 2 to isolate the variable, and we get x equals 22. All right, last step, just make sure when you plug it in, you can't have a negative. All right, you can't have log of a negative. All right, so then the next one, there's a little bit more going on, but still, you're doing the same thing. You need to say log plus log, let's put it into a single log. So that's going to be log base 5 of 3 times x plus 5. Better put that in parentheses there. Equals 2. Okay? So there's that one looks a little tricky, but essentially you just have to multiply those. And if you can do that in your head, it's going to be distributive property. 3x plus 15. That's 3x plus 15. So we have log base 5 of 3x plus 15 equals 2. All right. Now, we don't want to say 3x plus 15 equals 2 because we have to think about why we get rid of the logarithm. We do need to get rid of that logarithm, but this one's different. Okay. On the last problem, we did a base 8 on both sides, and it canceled out the log that was on both sides. All right. So on this one, we're going to have to do something similar. If I want to cancel out that log base 5, I'm going to have to do a base 5 on both sides. Okay. A base 5 on both sides. And it will cancel out on the left side, but it doesn't cancel out on the right side because there's nothing to cancel out on the right side. You just have 5 squared. And you should know 5 squared is 25. So 3x plus 15 equals 25. At this point, you've got an equation that you've solved a million times. We're going to subtract the 15 over and get 3x equals 10. 3x equals 10 and divide by 3. We get a fraction, but so what? You've got a fraction, 10/3. Okay? You could say 3.3 repeating if you want to use the calculator and get a decimal. So number 7 is going to do kind of the same thing. A little bit easier, but pretty much the same thing. First step, though, we want to get our logs together. Log minus log, you can condense to a single log by saying that's log base 8 of x divided by 3 equals 2. All right? We're trying to isolate the variable. We know we're going to multiply by 3 later, but we got to get rid of that log base 8. How do you get rid of a log base 8? With a base 8. We're going to take a base 8 on both sides to cancel out. So x over 3 equals 8 squared. 8 squared is not 16. 64, right, because it's 8 times 8, not 8 plus 8. X over 3 equals 64, at which point I'm going to multiply both sides by 3. 64 times 3. Let's see, 60 times 3 would be 180. 4 times 3 is 12. I got 180. I got 12. That's 192. Use a calculator if you need to. Again, the last step should be, think about your answer. If it's going to be negative, it's going to be negative, then you can't have it. All right, x equals 192. Question? All right, next one, number 9. Again, first step seems to be the same in every one of these problems. I need to condense my logs into a single log. So that's going to be log base 5 of x times 7. So change your plus into a times. X times 7 or 7x equals log base 5 of 73. All right. Notice you've got a log on both sides this time. So if you've got a log on both sides, then it's going to cancel. Your base 5 is going to cancel on both sides. And so this goes back to one of the first problems we had where everything canceled out and we didn't have to do that exponent thing. 7x equals 73. Divide by 7. Is, 10.46. Is that what you said? 10.43. Okay. If you want to do that, you do that. But if you want to leave it as a fraction, it's 73/7. And you said that was about 10.43 on a calculator. Either way. Okay. Number 11. Condense. We know subtraction changes to division. We're going to raise both sides into the exponent by using a base 2, which is going to cancel my logarithm, give me x over 9 equals 2 to the third power is 2 times 2 times 2, not 6. It's not 2 times 3, it's 2 times 2 times 2. That's 8. And then last step, just ISO the variable. We're going to multiply both sides by 9. 8 times 9, 72. Subtraction changes into what? Division. So 5x over 3. And division does have to be in that order. You have to do the first one divided by the second one. Multiplication is interchangeable, but division is not. Okay, log base 6 of 5x over 3 equals 1. What are we going to do now? Okay, base 6 on both sides, yes. To cancel, I've got 5x over 3 equals 6 to the first power is 6. Very good. If I'm going to ISO the variable, I'm going to multiply both sides by 3. That gives me, I'm going to move over here, 5x equals 18. 5x equals 18. Divide by 5. Bless you. And we can call that a fraction, 18/5. Or if you're on a calculator, what would that be? Like 3.6 maybe? I think you can say 3.6 here. Either way. All right, last one. Last one. It's always going to be harder when you've got those parentheses showing, but the first step on this worksheet seems to be the same thing every time. Log plus log, we're going to change that into a single log with multiplication. All right. So if you want to skip a step, you'll be able to multiply those two things in your head, or distribute in your head. If I distribute, that's going to give me 6x minus 30 right there. Equals log base 4 of 45. Everybody know where I got 6x minus 30? I just multiplied. I skipped a step, right? And so in this problem, I want to do a base 4 on both sides. That's what it's called, base 4. When you're trying to communicate about this problem, what are we doing? We're taking base 4 on both sides. We're raising both sides into the exponent of a base 4. That's going to cancel out my log on both sides. Gives me 6x minus 30 equals 45. After this, it's a straight solve. Do what we always do. Add the 30 over. That's going to say 6x equals 75. Divide by 6. X equals 75 over 6, whatever that is. 12.5? Okay, good.